students, myself Rajesh, Assistant Professor in the Department of ECE, B.V. Raju Institute of Technology, Narsapur. Today we will discuss the course as DCN, Data Communication Networks. And today we will discuss overall the course outcomes, okay, what are the different types of objectives and what are the units, and the unit 1 introduction we will see today. Next, okay, for this course DCN, Data Communication Networks, we need to have the prerequisition. Okay, here we are having the analog and digital communication part, whereas here in the main objective with the digital communication is we are having the some digital communication topics or concepts which are present in this. Okay, like FDMA, multiplexing, TDMA, FDM, like that we are having different types of multiplexing techniques here. So we have involved prerequisite as an analog and digital communications. And here we will see the course objectives. Okay, first course objective is general idea of data communication. Okay, what is meant by a communication, data communications, and networking, and what are the various types of protocols present, and standards and the network reference models. Okay, all these things we are going to see as a course objective as first point. And then coming to the multiplexing, connecting devices that can be used for data communications. Okay, and then how the data is corrupted, how these errors can be detected and corrected in wired and wireless LANs. Okay, these are the other objective. And the fourth objective is to know about the IP addressing. What are the different types of addressing techniques, IP addressing, IPv4 and IPv6, like that we need to know about this IP addressing. What are the different types and how the IP addressing is framed. And then coming to the last point, data routing with various routing protocols. Okay, data routing using various routing protocols at network layer issues. Okay, we will see all this as an course objectives. And then coming to the course outcomes. After completion of this course, what are the students can be able to learn? Okay, first one, the functions of various data communication networks and the various transmission media and multiplexing techniques. Okay, transmission media and multimedia techniques, wired and wireless, like that everything we will see in detail. And the third one is the data link layer and various error detection techniques. Okay, data link layer and various error detection techniques that can be understood. And then the demonstrative mechanism of routing in the data network layer. Okay, routing mechanism. And the last one is various flow control, congestion control, and mechanisms and functions of various application layer protocols. Okay, these are the 5 course outcomes regarding to the data communication networks. And then coming to the unit 1, we are having the classifications of computer network. First of all, before going to that, what is meant by a computer networking, what is meant by a networking devices, everything we will see. And then coming to the classifications of computer networks. This is regarding the syllabus. And then the next point is the network architecture. And then the network applications. And then computer network types, LAN topologies or LAN technologies, computer network topologies, network security, and then network models, layering, protocol layering task, OSI model, TCP IP protocols. These two are the very important, OSI model and TCP IP protocols. And then last topic in the first unit will be the comparison between the OSI and TCP IP reference models. Okay, this is regarding the first unit. And then coming to the second unit, this second unit is taken from the one of the layer in the OSI model or TCP IP model. That should be the physical layer. Regarding this physical layer, we are going to see that signals, what are the different types of signals, how the signals will be found, and the transmission impedance, and the transmission media and channel capacity. Okay, in the transmission media, we are having guided transmission media, unguided transmission media, and the channel capacity, bandwidth, error rate, encoding, and transmission modes. And then multiplexing. Okay, FDM, TDM, WDM, CDM. And the network switching, circuit switching, message switching, packet switching, and the networking devices, hub, switch, routers, and gateways. These are the various topics which are present in the second unit, unit 2. And then coming to the third unit, we will see here regarding the data link layer, okay, which is the second layer from the bottom. Okay. For this, what is meant by node, links, services, categories of links, sublayers, network layer addressing, types of addressing, and ARP, address resolution protocols. And then the second topic is data link layer protocols, whereas simple protocol, stop and wait protocol, piggybacking, and then coming to the multi-access control. Multi-access control. In this multi-access controls, we are having the random access control protocol, random access protocol, control access protocols, and okay, channelization protocols. But here we have taken the random access and controlled access protocols. Okay. For this random access, we have seen the Aloha. In that Aloha, we are having slotted Aloha and pure Aloha, CSMA, CSMA CD, and CSMA CA. Collision detection and collision avoidance. And then coming to the collision access, resolution protocol, polling, token passing. These are the various protocols which are present under the controlled access. And then coming to the LANs, wired LANs. We will see the Ethernet and wireless LANs. This is regarding the unit 3. And then coming to the fourth unit, here we have taken the network layer. For this network layer, what is meant by packetizing, how the packetizing will be made, and routing and forwarding techniques and other services of the network layer. And then second topic is the packet switching. In that packet switching, datagram approach and virtual circuit approach techniques are there. And then IPv4 addressing and IPv6 addressing. Okay, for this classful and classless addressing, everything we will see under this. And then DHCP. And then IPv2, IPv6 transitions. And the next topic is network layered protocol, where here we will see about the IP protocol, datagram format, fragmentation, okay, ICMPv4 and messages. Okay, Internet Control Message Protocol version 4. And then the routing algorithms, distance vector routing, link state, and RIP, routing information protocols. These are the various topics which are related to the unit 4. And then coming to the fifth unit. This fifth unit related to the transport layer and application layer. Okay. In this transport layer, services, connectionless and connection-oriented protocols, how it would be. And then transport layer protocols. Simple protocols, stop and wait, go and back, selective repeat protocols. These are the various types of protocols which we will discuss in this unit. And then the user datagram protocol. Here user datagram, UDP services and UDP applications we will see. And the TCP, UDP and TCP both we will see here. Here for TCP we will services, features, flow control, error control, and TCP mechanism, control access. Everything we will see under this transmission control TCP protocols. Okay. And then the last few points are application layer related to that. We will see the client server model, protocols related to the application layer, DNS, SMTP, FTP, POP, and HTTP. Okay, domain name system, simple mail transfer protocol, file transfer protocol, post office protocol, hypertext transfer protocol. These are the various types of protocols related to the application layer we will see in the fifth unit. Fifth unit is the combination of transport layer and application layer. Okay, like that every unit is covered different layers. Okay, which will be taken from the TCP/IP reference, TCP/IP model. Okay, coming to the first unit, what is meant by a computer networks? Okay, it is a combination of different computers or different devices which are going to interconnect. Connection is made for transferring of resources and sharing of some information. Okay, this is regarding to the computer network definition. And then coming to the what are the different types of computer networks? LAN, MAN, WAN, PAN. Okay, these are the four types. We'll see one by one. PAN, personal area networks. Okay, if you use our mobile phone with the help, we can access our internet by other person with our mobile phone. We'll use the it may be a Bluetooth sharing or infrared or hotspot. Everything comes under this PAN, personal area network. It will be the distance between few 1 to 100 meters within a room. Okay, transmission speed is also very high with the help of this PAN. Okay, 1 to 100 meters or within the room it can be used. Personal area. Okay, here we will observe the PAN, personal area network. Okay, with the help of this laptop we can share headphones, Bluetooth, okay, mobile phone, laptop, another laptop, wireless mouse, wireless printer or scanner. Everything will be under the PAN, personal area network. And then coming to the second one, we're having the LAN. LAN, local area network. Local area network. Okay, for this, which is also a limited area, like PAN, which is also having some limited area within the building or within the school or within the library or within the college. You need to network some computers. Okay, we are going to design some networking within the college. Okay, few devices are interconnected. This is LAN, local area network. Okay, here we will see 1 to 100 meters for PAN. For LAN, it may be up to 2 kilometers range. We can access the internet regarding to the LAN, which is also of high speed of data transmission. Okay, and also with the of low cost. Okay, maintenance cost is also very low for this LAN. Okay, few applications means where we can use this within the school or within the building or within a single office, like that we can use until the area which covers 2 kilometers. And then coming to the next one, MAN, metropolitan area, third one, metropolitan area. Okay, here from 3 kilometers up to 2 kilometers we have seen LAN. From here, the metropolitan area, we will having 5 kilometers to 50 kilometers range. Okay, 5 to 50 kilometers. Okay, within the city or within a local area, some area like Hyderabad or Secunderabad, both will come under, okay, 50 kilometers range. So, metropolitan area. Okay, it is the combination of few LANs. It is a combination of few LANs. Here, the speed may be average. Why? Because it is a large city, large networking. So, the speed may be a moderate high speed. A city or a town. Okay, combination of towns like that we will have. And then coming to the WAN, wide area network. Wide area network. It is a combination of WANs and LANs. Okay, here we will observe this. In this is one network, and this is another network, and this is another network. All these networks are combined with the help of the WAN, wide area network. Okay, it is having the range above 50 kilometers, more than 50 kilometers, and the transmission speed is very low. Why? Because it is a combination of above 50 kilometers. The systems are interconnected, so its speed also may be, transmission speed also may be decreased. If the bandwidth is more, then it is okay. Okay. For this, an application with respect to this WAN is an internet. We'll see. Okay. This is regarding the types of computer networks or classifications of computer networks. Okay. You can need to remember this: PAN, LAN, MAN, and WAN. And then coming to the next topic, types of computer network. Here we will see the P2P networking and client-server model. Client-server network. Okay, P2P network, peer-to-peer network. We will see this. This is an example here. All the systems which are present in this network, each system is connected to every system which is present in that network. That means point-to-point delivery. Suppose this is A system and this is B system and this is C and this is D, E, F. Like that, we are having few systems which are connected in that network. I need to transfer from A to B. Directly I can transfer. A to F, I can CAC. Okay. And A to E. Directly I can access. Like that, point to point communication from one system to another system. Directly I can contact with that. Okay. This is regarding the peer-to-peer networking. And then coming to the client-server network. Client-server network. Here in this client-server network, server is one side and clients are another side. These both are combined with the help of the networking. Okay, with the help of the internet, we are going to exchange the information from server to the clients and clients to the server. Exchange of information in between the client and servers with the help of the internet. Okay, that means the client-server network. Clients are mobile phones or laptops or desktops, and the server is other side. It may be a Google server or Yahoo server or any other private servers. But we need to, if you want to access that server, we need to have some internet as a mediator. Okay, this is regarding the types of computer network, P2P network and client server networking model. And then coming to the some important network components. If you want to design a network by combining the few devices or computers with the help of some other devices, okay, from that we are having the few devices like NIC, okay, network interface card, switch, cable, hub, router, and a modem. Okay, for NIC, observe here, this is the diagram as it looks like this network interface card. Without this network interface card, we can't access internet. Okay, with the help of this card only, our systems, or whether it may be computers or laptops or any other, we can access the internet with the help of this. Okay, and then coming to the next one is switch. It looks like this switch. Okay, where we can have the multiple computers which are going to interconnect within a room with the help of the switch, as just like a hub. Hub and switch are both are the same, but there is a disadvantage between, and there is a lot of difference between them. Okay, switch is also hub and switch both are looking like the same. Okay, this is a switch and this is a hub. Here you can look into the hub. We are having 1, 2, 3, 4, 5 up to 8 systems we can add. Whereas switch we can add more number. We can increase the number of connecting devices into a single network. Okay, up to 100 switches, 100 systems can be connected to the switch. Whereas in hub we can connect up to 8 systems. Okay, there is a lot of difference between hub and switch. What is the main difference? Okay, with the help of the hub, if you want to send any information which are connected in that particular network from one system to another system, the message will forward to all the systems which are connected to that. For example, A, B, C, D. Like that we have connected 4 systems to this hub with the help of the hub. If you want to transfer from A to D some message, A, B and C also receives the same message, but it rejects. Only A, D will receives. That means duplicates of data is framed. Okay, unknowingly or knowingly B and C also receives the information where A sends to D only. Whereas coming to the switch, if you connect a few devices A, B, C, D, A wants to send to D. Okay, A directly can to send to D without the intervention of the B and C. Here why? Because it is switch is having some table. In that table, IP address and MAC of particular system will be noted down in the table. With the help of this MAC ID, the message want to reach will be sent directly to that particular MAC ID of that particular system. So there is no interface. Okay, this is the main difference between the hub and switch. And then coming to the cables, how these cables look like. Okay, here this is the example how we can connect these cables to the ports. Okay, this is a cable. It's look like a twisted pair cables for network transferring. Okay, for internet purpose we are going to use these cables. And then coming to the router. Okay, router and modem. Router is an intermediate between the transferring of information from one network to the another network. Okay, suppose this is one network which is having some few systems inside it. This is another network which is also having some systems or some internet network. We need to transfer some message from here to here, but you cannot access directly. But with the help of the router, we can access or we can send and receive some messages from different networks. Here this is an example, and one more example. This is the router R1 and R2, two different routers, and this here having a switch, and this is also having another switch. For this switch we are going to connect few systems, few PCs. Okay, PC1, PC2, PC3, like PC6. This router which is connected, this is one type of one network 1, and this up to here it is network 2, and this is the network 3. Okay, for this for example one IP address for this network 192.168.10.1. But here this is different network. So 182.168.10.1, another different network. Okay, like that with the different networks we are going to have interconnect with the help of the routers. Without routers, we cannot access the data from different networks. We cannot send and we cannot receive the data between the different networks without routing or routers. Okay, and then coming to the modem. If you want to use some internet, we require a modem. Okay, this is the example here. You can observe here. This is an modem 1 and modem 2. Okay, from this modem we are getting a signal from the BSNL office or Airtel office. From that we are getting the signal into the modem. From that modem we are getting an output with to the telephone network. Okay, from telephone network we will connect to our system or laptop or any other thing. Okay, this you can access the internet, okay, with help of the modems. This is regarding the few important components of a computer networking. And then see the LAN technologies. First one, Ethernet. What is meant by this Ethernet? How it can be? Okay, this is one of the Ethernet means LAN cable we are going to connect to our PCs. Okay, this is one of the LAN technology. Ethernet, fast Ethernet and Giga Ethernet. All these are the different types of Ethernet speeds based on the different speeds. First we will see this Ethernet and then we will go for fast Ethernet and Giga Ethernet. Coming to this Ethernet, this is one of the standardized of IEEE 802.3. Okay, IEEE 802.3. This is the IEEE standards for an Ethernet access. Okay, with the help of this Ethernet protocol, we are having the speed may be vary. For Ethernet, it may be of 10 base T. Okay, here 10 is the maximum speed. That is 10 Mbps. Up to 10 Mbps, the speed can be accessed. And this is the base means baseband. And T is the thickness of the internet. Okay, thick Ethernet or internet. Okay, this is the main difference with respect to the fast Ethernet and Giga Ethernet. For Ethernet, it is 10 base T. 10 is the maximum speed of that particular network if we use an Ethernet, normal Ethernet. If we go to the fast Ethernet, before that Ethernet, for which type of cables that can be used for Ethernet, like that if you see here we can use twisted pair cables. Normal Ethernet cables we are going to use in our systems or in our labs, we will see. Okay, actually twisted pair cables that can be used. Okay, here maximum the topology which is used in this Ethernet means star topology. Star topology technique is used in the Ethernet. Okay, where up to 100 meters, the length will be the 100 meters, that speed can be used. Okay, and also RJ45 jacket, okay, cable connector, that will be here, RJ45. Okay, and then coming to the fast Ethernet, here 10 for Ethernet, 10 base. For coming to here 100 base T, that means 100 Mbps. Okay, up to 100 Mbps speed we can use here, 100 Mbps speed. Whereas here IEEE Ethernet format is the protocol is IEEE 803. Here 803.2. This is the Ethernet protocol where it is used in the fast Ethernet. It is on speed of 100 Mbps per second. Okay, speed is increased than Ethernet. Here also you can use can go with optical fiber cable as well as Ethernet also. Just like for Ethernet we have used twisted pair cable with that, and also we are having the optical fiber as an optional. Okay, for fast access we can use the optical fiber cable. And also the length should be the 100 meters. 100 meters for half duplex. And then 2000 meters for full duplex. Okay, full duplex. Okay, for half duplex one-way communication we can go with 100 meters. For full duplex we can go up to 2000 meters. Okay, here where we are going to use the cable is optical fiber cable. And then coming to the last one, Giga Ethernet. Okay, for Ethernet 10, for fast Ethernet 100, for Giga means 1000. Base T. Okay, 1000 base T. That is fast Ethernet. Giga Ethernet. Okay, 1 GB of speed. Here speed is 1000 Mbps. Okay, 1000 Mbps speed. And then here Ethernet protocol it utilizes is IEEE 802.3AB and 802.3AH. These are the two IEEE protocols which can be used here. AH and AB and AH. These are the two different types of IEEE protocols which are going to be used in the Giga Ethernet. For AAB, IEEE 802.3AB, where which type of cable that can be used here? For this, which type of cable that can be used here? Okay, for this AH, we are having the optical fiber cables that can be used here. For AB, we can use as UTP. Okay, twisted pair cable. Okay, that going to be used in the Giga Ethernet. This is regarding the Ethernet LAN technologies. Ethernet, fast Ethernet, and Giga Ethernet. Based on the IEEE protocol, it has varied the speed. And then coming to the different types of computer networking topologies, different what is meant by topology and what are the different types of topologies which are present in here. Okay, what is meant by a topology? The way are connected in a network. Okay, the way we are going to connect the devices in a network, either it will be a ring type or circle type or straight as a bus type. Like that, we are having different types for data transferring between the network. Okay, for this we are having the different types of topologies: point-to-point topology, mesh topology, star topology, bus topology, ring, tree, and hybrid topology. Point-to-point means from one system to one system directly we can contact. Suppose if there is 5 systems in the network, one to one directly contact. Point to point, A to B or A to C, A to D, directly we can contact with the point to point networking. And then coming to the mesh topology. Before that mesh topology, we will see the bus, ring and star topology. Then we will come to the mesh topology. Okay, coming to the bus topology, we are having the bus. Okay, bus means a way. For this bus, we are going to add few systems. Okay, this is the way we can connect these systems. Okay, with the help of the bus, we cannot access directly connected. For theoretically, we can explain by drawing like this. System A, B, C, D, E, F are connected to the bus, and then they can transfer the information one by one. In practically, we can not go like this. In practically, we can place a switch or hub in place of a bus. Okay, either a switch or bus we can place here. And then coming to the ring topology. Okay, this is the bus topology. And coming to the ring topology. Okay, system A, B, C, D, E. Like that, every system is combined just like to form a ring. Okay, A is connected to B, B is connected to C, C is connected to D, D is connected to E, E is connected to A. Okay, C is directly not connected to A. If you want to transfer some information C to A, they need to come here in this direction or in this direction. They need to come from in this direction because it is the shortest distance. Okay, one disadvantage is there here is if any network or a connection between two devices is disconnected, then we cannot transfer the information or we cannot share the resources. Okay, this is a main wrap related to the ring topology. And then coming to the bus topology, already we have seen. And then coming to the star topology. Star topology means you are having the one system. Okay, system A, B, C, D, E. These are the systems which are connected in the form of a star, where here we cannot access the system here. It may be a hub or switch as a mediator in between the 5 devices. Okay, if A transfer to C some information, we need to transfer through hub or switch only, centralized device. Okay, every data what the other devices want to transfer or resource that can be shared through with the help of the switch or hub. Okay, centralized. Every data will be shared in the centralized node. Okay, this is related to the star topology. And then coming to the mesh topology, just like here. Suppose these are the few systems is there, A, B, C, D, E. Okay, 5 systems. Each system is connected to each node. Okay, A is connected to B, A is connected to C, A is connected to E, A is connected to D. Like that, every system is connected to the individual other systems in that particular network. Every system is connected to every other systems which are connected in the particular network. That can form the mesh topology. Okay, directly they can access. If one system is down, you can go with another path. Like that, there is a lot of advantage in the mesh topology. And then coming to the hybrid topology. It is the combination of either one or two different types of topologies. Okay, hybrid topology. Suppose bus topology, ring topology, mesh topology and star topology all are interconnected each other. Then it is from a hybrid topology. Combination of two or more different types of topologies. Okay, bus ring, ring star, okay, hybrid, like that we can have this. And then has the tree topology. One is the basic one. From this we are going to have increase the just like tree, increasing the devices. Tree topology in the form of a tree. For a tree we are having so many different types of branches now. Like that, for the server main system we are connected with other sites, another local. Okay, just like a LANs are interconnected. Okay, this is regarding the different types of network topologies. And coming to the next point, transmission mode. On what way we are going to transfer the information after the physical layer. Okay, physical layer after that physical layer, how we are going to transfer the information from one place to another or send it to receiver. On what way? Either a two-way or one-way or any other possibilities are there. That we will see here. Okay, transmission mode. What is meant by transmission mode? Okay, this is the mode or a method that transfers the information between the devices. Between the devices, known as communication mode. Okay, transmission mode is of 3 types: simplex mode, half duplex, and full duplex. I'll say one by one. Simplex mode means only one-way communication. Here, this is an example for simplex. Simplex example from PC1 to PC2 or A to B, sender to receiver. Directly we are transferring information only one way. There is no return back. Just like I am telling that I have received your information, I have received your data. Like that, there is no acknowledgement will be there. Just A will send the information to B. Either it receives or not, we don't bother about it. That is related to the simplex mode. For example, for the simplex mode is keyboard or mouse. Okay, this is the only one-way communication from keyboard to CPU. From CPU to keyboard, it will be not there. Okay, like that, this is an example for simplex. And then coming to the half duplex. For half duplex, we are sending some information from A to B. After receiving that information, B will send back an acknowledgement. Okay, both at a time is not possible here. Okay, after receiving the information from A to B, then only after that B can respond. Just like an walkie-talkie. If one person talk, another person will listen. If he wants to talk, another person need to be listen. That's it. Okay. One person is active, another person is silent. This is related to the half duplex. And then coming to the full duplex. Observe here two ways, two lines is there. One for sending and for receiving. Both can be parallelly done. We can speak and we can listen. We can speak and listen parallelly. Both we can speak parallelly. It is related to the full duplex. Just like a telephone line, telephone or mobile phone. We can speak and he also speak. Both can argue at a time. Okay, this is related to the full duplex. Another one more is there. Full duplex by full duplex. FD by FD. Full duplex by full duplex. That means another PC will add here. Okay. From here to here it receives. From here to here it sends. From here to here it receives and sends. Okay. One systems will play both dual role. Here, from here to another system, from here to this side. Okay. Both way. Parallelly. Dual role can play one system. One device or one person. Okay. This is related to the full duplex by full duplex transmission mode. These are the different types of transmission modes. And then we will see the protocol hierarchies. Okay, here what is meant by a protocol, what is meant by a protocol hierarchies, what are the key elements of a protocol, that we will see here. Protocol, what is a protocol? Simply we can say that it is a set of rules. Set of rules for what? For data communications. That is what here written here. A protocol is simply defined as a set of rules and regulations for data communications. Okay, rules are step-by-step process at the time of communications among two or more computers. This is regarding to the protocol. What is meant by a protocol means it is a protocol which is defined as a set of rules and regulations for data transmission. Okay, step by step how the process will be done. This is related to the protocol. And then coming to the protocol hierarchies. Protocol hierarchies. Okay, check here. Computer networks are compromised or contain large number of hardware and softwares. Okay, a computer network is having the large number of hardwares all will be there, different types of softwares will be there, they need to be integrate each other. Okay, and then for network design, various networks organization arranged a stack. Okay, stack of layers or hardware, software one by one. Okay, that means, okay, we are suppose if we take a different layers, suppose we will take a 4 layers, we are having the different layers. Here in this layer it has some set of rules of its own. Here it is having some other set of rules. Here it is having another set of rules. Here it is also having another set of rules. For each device, each layer, there is some set of rules and hardware components and software, different software components here. All this to be integrated each other. One to one should be communicated. Okay, this is reading by the protocol hierarchies. And then coming to the what are the key elements of a protocol? The key elements of a protocol: syntax, semantics, timings. Syntax means the way how, the format how we can write the program. And then coming to the timings, on what time the message need to be sent and what time the message to be sent and received and how the speed can be sent. Okay, and then semantic, on what way the message can be communicated. Okay, all these 3 key elements of a protocols are very important. Okay, this is related to the protocol hierarchies, which till now we have seen the first unit, half of the first unit we have covered. Okay, thank you. We will see in the next class the continuation of the first unit regarding to the OSI model and the TCP/IP model in the next session. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.